Today I'll be covering the Unit 12 review key on the calculus and limits. So for question 1 here, I want us to complete the table below, which you can see I have already done. How you would get these numbers is you would take these x values and plug them into this equation up here. You can also create a table on Desmos and you'll get these numbers fairly quickly. I just put these in to begin with to save some time. What's asking you to do is to figure out what number, if you follow the pattern from both the left side and the right side, should go where this undefined is. All right, so the limit as x approaches 0 of that function. What number should go for that y value? And as you can see, it's getting really, really close to the number 0. It's approaching 0. It's the number that should go there, so that's going to be our answer. For question 2, they're all going to be based off of the same graph here. It's going to ask you to do things like, for example, find f of negative 2, and f of negative 2 is right there. Right, so we'd write just a positive 3. That's all it's really asking you to do. See if you can find some limits as well. So limit as x approaches negative 2 instead of f of negative 2. So that's what's it approaching both sides of negative 2. And it's getting really close to negative 3. Right? So if you want to take a few minutes and see if you can find the other ones here, answer the questions C through H. I will pause the video and return in a second. And so here are the answers for the rest of question 2. Parts C, D, E, and G are very similar and straightforward. Question D is the limit from the left side, and question E is the limit from the right side. So those are the only things to be careful about. For question F, this is not continuous because there is a gap here. There's a gap right there, which means the left and the right limits don't match, so that there cannot be continuity there. It's not continuous. It is continuous at x equals 3 right there because the limit is the same as the actual value there. So I'll move on to question number 3. It says the graph of function f is shown below. If limit of f of x as x approaches b exists and f is not continuous at b, then b equals what? So we're looking for a spot where the limit exists but is not continuous. Right? So we want a spot where there is a limit but there's either a hole or a gap. But if there's a gap, it's not going to have a limit. If it's an asymptote, it's not going to have a limit. So we're looking for places at holes. Right? And this is the only hole where it's got a limit, is at x equals 0. So our answer will be B. For question 4, this one will have 6 parts. This may be the hardest section of the test. But for question A, if you have limit of a number, if your function is a number, then it just equals that number, no matter what the x value is. So this will just simply equal 7. For part B, what you can try doing is plug in that negative 3 for both x's. Right? So this will be negative 3 squared plus 3 times negative 3, which is 9 plus negative 9, which is a 0. Right? Sometimes you'll get a question that looks like letter C, where if you plugged in a negative 4 here, you will get a divide by 0 error. So what you should do then is, in a case like this, is you should factor both the top and the bottom if possible. So the top can't be factored. We're going to leave it as it is then. But the bottom can be factored. And since our goal is to cancel some things out, one of those factors will have to cancel with one of the factors in the top. So that's going to be an x plus 4, and our other one will be x minus 4. Right? So the x plus 4's will cancel out. They'll go away. We'll be left with just the limit as x approaches negative 4 of x minus 4. And now I can take that negative 4 and plug it in. So, or actually it's 1 over x minus 4. 1 over x minus 4. I can take that negative 4 and now plug it in. So 1 over negative 4 minus 4, which is going to be negative 1 over 8. Right? Negative 1 over 8. Part D, we have a function that is not factorable, so what we're going to do is rationalize the denominator. How we're going to do that we're going to multiply the top and bottom by the conjugate of the bottom. So that's the one with the square root, the one that needs rationalizing. Right? So the conjugate is simply x squared of x plus 4 instead of minus 4. And when you multiply this out, essentially what's going to happen is that the bottom side, the denominator of the two terms will just simply square. So you have x squared of x squared, which is just x, and then you have 4 squared, which is 16. And then on the top, you should have x plus 2 times a square root of x plus 4. And then when you plug, you should be able to plug in 2 now and get an answer. When you plug in 2, this will equal 4 over the square root of 2 minus 4 when you simplify. Plug in and simplify. Okay, so that's rationalizing the denominator. You can do the same thing for part F. So if you would like, you can try part E and part F on your own and see how they work out for you. And come back in a few seconds to check your work. Alright, if you make it through E and F, you should get the answers of negative 1/12 and 1/6 using either factoring or rationalizing. I'll move on to the next page, so page 5. It says assume that the limit as x approaches c of f of x equals 2, and that limit as x approaches c of g of x equals 8 to find each limit below. So what we can simply do is, for part A, we can do 5 times 8, because we know the limit of g of x is 8, so 5 times 8, and then we can also add a 2 times 2. So 5 times 8 is 40, 2 times 2 is 4, so this will equal 44. Simple as that. Part B, we can just do limit of g divided by x. So we know the limit of g is 8. We know the limit of f is 2. 8 divided by 2 is 4. All right. For question number 6, this is going to be the process of finding the derivative by the limit definition, and then writing an equation for a tangent line. So what it's going to ask you to do is first find f of x plus h. What that means is you're going to take x plus h and put it in for x everywhere in the equation. So instead of x squared, you have x plus h squared. And you're going to subtract, instead of 5x, 5 times x plus h. And if you work this out and simplify it, this will all come out to be x squared plus 2xh plus h squared minus 5x minus 5h. Right? It's a lot of terms, it's a lot of stuff, but what's going to end up happening is things are going to cancel away and you won't have to work with quite so much stuff. Right? So for part B, it's asking you to take your answer from part A, so this is your answer from part A right here, and then subtract f of x. Right? So your answer from part A is x squared plus 2xh plus h squared minus 5x minus 5h, and you want to subtract f of x. So f of x in this case was x squared minus 5x, right? And if you simplify this, some things are going to cancel out for you, so you'll be left with just 2xh plus h squared minus 5h. Right? And part C will ask you to take your answer from part B, that's the top here, the numerator, and write an expression for f prime of x or the derivative. So you're just going to take your answer from part B and plug it in for the numerator there, so you're going to get limit as x approaches 0 of 2xh plus h squared minus 5h divided by h. Right? If you notice now, every term has an h in it, so we can cancel all those out. You can divide out an h from everything. So this will equal the limit as x approaches 0 of 2x plus h minus 5. And then lastly, I can take this 0 right here and plug it in for h to find my limit. So what it's going to look like is 2x plus 0 minus 5, right? And simplifies to 2x minus 5. And that is going to be our derivative, is 2x minus 5. So we can use that derivative in part D to find the equation of a tangent line. So remember, when we write equations of lines, they're in the form of y equals mx plus b. We will need to find the slope, and that's what we use our derivative for. Derivative finds the slope for us. So f prime of x, we specifically need f prime of 3, because that's our x value at the point. So f prime of 3 is going to be 2 times 3 minus 5, which is 6 minus 5, which equals 1. So our slope is 1. Thankfully, we have a y and an x value already for us, so we can plug those into our equation to help us find b. So negative 6 equals 1 times 3 plus b. And so if we solve this all out, we should get negative 9 equals b, right? And then if I write an equation, I can just fill in m and b. So y equals, m is 1, so just x, and b is minus 9. So that's going to be my equation of my tangent line. And that's the line that will be tangent to my graph x squared minus 5. Right? And then moving on to our last page, question 7, is using the power rule. Power rule is fairly basic, fairly simple, straightforward. It just helps us find the derivative really fast instead of using that whole limit process. We can bring down the power here. So 2 times 7 is 14, and subtract 1 from that power, so we'll have 1x. And then the derivative of x is just 1. And the derivative of 8 is 0, so we don't need to write anything for that. For part B, I would write this in the form 3x to the negative 4th power. And then you can use your standard power rule on it. Just make sure you're subtracting 1 and not adding 1. So if you then simplify, you end up with an answer of g prime of x equals negative 12 over x to the 5th. For question 9, we have a diver jumping off of a diving board. It has a picture for us as well. So you want to know when the diver hits the water, so you want to find s of t, when s of t equals 0. If you put that into a Desmos or solve it any other way, you will get t equals 2 seconds. Right, and then the diver's average velocity is just the rate of change, so that's going to be s of 2 minus s of 0 over 2 minus 0, which, if you work that out, will be a negative 16 feet per second. So for s of 2 and s of 0, you just plug in 2 and 0 to the equation and go. Alright, and then for part C, to find instantaneous velocity, you need the derivative of s of t, which, if you follow your power rule, will be negative 32t plus 16. And then you plug in 2 for t. So v of 2 is negative 32 times 2 plus 16, which is negative 48 feet per second. Right? And that's the entire review. If you have questions, please let us know. Otherwise, good luck on the test.